Okay, now we're going to look at properties of sine functions, and specifically we're going to talk about how to graph them as well, okay? So let's look at the properties of sine functions. So let's suppose that we have y equals a sine b theta. Now this theta is just taking the place of what you're used to seeing an x, but when we start looking at trigonometric functions, they replace that with an angle theta, because when you're looking at your x, then you're looking at an angle. And we, in math, normally represent angles. The variables we use to represent them is this Greek letter of the alphabet called theta, Theta. Okay, so this is called theta, but it's very similar to an x for you. Okay, so it's similar to x. All right, now, so the first thing you need to know is the amplitude of the function if you have a graph that looks like this. So the amplitude of your function is the absolute value of a. Now remember that amplitude, we got this definition yesterday. Amplitude is 1/2 of the maximum value minus the minimum value, okay? So in other words, that amplitude is going to tell you how high and how low this thing goes, okay? So the absolute value is the amplitude of the function, absolute value of a. Also, b, this b right here, is the number of cycles in the interval 0 to 2 pi. So remember yesterday we talked about the cycle of a sine graph. So however many circles are in that interval 0 to 2 pi, however many cycles are in that interval 0 to 2 pi is going to be represented by this b. So let's do some colors here just to help you. So the amplitude A, that's that one. And then this B comes from right here, that B, okay? Also, 2 pi over B is the period of your function, okay? That's the period of your function. Remember, that's how long it takes it to complete one cycle. So if you know this number, you can take 2 pi and divide it by this number, and that's going to give you the period of your function. And this right here is super important to know with sine graphs. This is the pattern for a sine graph. All sine graphs have a 5-point pattern. All of them have a 5-point pattern, and that pattern is this. They'll be at 0, which is on the x-axis. Then they go max, they go back to 0, then they go to a minimum, and then they go back to 0. Okay, so in other words, they do something like this. Okay, they follow that same path over and over, same cycle. So let's look at an example. What is the graph of one cycle of a sine curve with amplitude 2, period 4 pi, and a greater than 0? And it says, using the form y equals a sine b theta, what is an equation for the sine curve? Okay, so first of all, y equals a. Remember, a is the amplitude. So what is my amplitude here? My amplitude is 2. So the absolute value of a, that would be the absolute value of 2, which is 2. So I know that that's going to be this a right here. Okay, then I'm going to write sine. And b is the number of cycles in the interval 0 to 2 pi. So I'm actually going to have to graph this and see how many cycles I have before I know what that b is in the interval 2 pi. Now, notice, though, it has a period of 4 pi. So if it has a period of 4 pi, that means this has to go all the way to 4 pi before it's going to complete one cycle. So if I'm going just halfway to 2 pi, that means it's going to complete half of its cycle. So 1/2 of theta is what it's going to look like. Now, once you come up with this equation, you can actually go to Desmos, which is what I'm going to do. So let me go over here to Desmos. And we're going to graph this. 2 sine 1/2 x. Now, if you click on your graph, it's going to give you some points. So notice here we have the point 0, 0. All right, I'm going to come back to my graph, and I'm going to put the point 0, 0. Then I'm going to go back to Desmos. Okay, I'm going to click this point. That point is pi and 2. Okay, pi and 2. So now what I'm going to do over here on mine is I'm going to label this line right here is my pi. I'm going to label that as pi. So that goes up to, what was it, 2? Yep. So if this is 1 and this is 2, and this is going to go up to 2 there. Okay, let's go back to our graph. Now remember, this is a pattern. 0, max. Now it took 2 units for it to go to that 0, so it's going to take 2 units for it to go back to 0. Let's see if we're right looking at the graph. Okay, that's at 2 pi, which would be right. If that's pi, then this would be 2 pi. We go 2 places, that'd be 2 pi, and it's back at 0 again. Okay, so we've got something now that looks like this. All right, now it's going to go to, we've got 0, max, 0. Now we've got to find the minimum. So let's go down here and get the minimum of this. All right, the minimum, minimum is at 3 pi. And it's at -2. 3 pi, -2. So I'm going to come over here. I'm going to go 2 units. This will be 3 pi. And -1, -2. So now I'm down at this point. Okay? Then we've got to go back to 0. Now each of these have went 2 units. So that means that this one is going to be 4 pi. And it's going to go back to 0. But let's see if we're right. We go back to our graph. At 4 pi, we are at 0. Okay, sorry guys. So we are at 4 pi and 0. So I'm going to put that in, and now I can draw this graph in. So this graph looks something like that. Okay? Right, now I would like for you to pause the video. I have given you the graph 1/2 sine 2 theta. And you're going to replace theta with x. Remember, when you key it into Desmos, replace that theta with x. But I want you to go key that in, pause the video, and then come back and let's see how you did. Okay, hopefully you have graphed this. So I've got 1/2 sine 2x, and it looks something like this. I'm going to zoom in a little bit so I can see here. So I've got this point 0, 0. I'm going to plot that on my graph. I'm going to plot these, and then I'll take it back and let you see. Okay, then I have pi over 4, which is at 1/2. That's at 0.5. Okay, and then back to 0 is at pi over 2. So I'll take you back and show you my graph in just a minute. And then down here, 3 pi over 4 is at -1/2. Sorry, I marked it in the wrong place here. I'm trying to fix it. -1/2. And then to go back to 0, we are at pi. So at pi, we're back at 0. All right, so I've plotted all of my points on my graph, and now I'm going to draw my line in. So we have a graph that looks something like that. Desmos is going to be a great friend for you in graphing these sine functions. Okay? If you have any questions, let me know.